All right. So here, when we're talking about the signs of acceleration, what you need to remember is that a particle in rectilinear motion is speeding up when its velocity and acceleration have the same sign, and slowing down when they have opposite signs. So that's what we just went through. What I want you to do right now is break these up into time intervals and tell me when the when the particle is speeding up and slowing down, and then we're going to go through this together. Okay? And let's use that last one as times 7, because that's what we did on the previous graph. Remember where it's like kind of iffy? And remember, you need to justify your answer. You don't have to use words, you can use symbols. I just thought about something that just blew my mind. After the new year, you only have units 5, 6, and 8. Yeah, see? Just like blew my mind again. 5, 6, and 8.
That's it?
Wait, what about 7?
Well, we do just one small part of 7, but we do it in 5. 5's in 2 parts. It just kind of, I was like kind of thinking in my head, like, what's left? I know, right? I don't even know what unit they're on right now in BC, but although Mrs. Kim just said, why don't you teach BC next year? I was like, oh. You're so funny. All right, you guys ready? I took on pre-class honors this year. I can't. All right, guys, let's take a look. So I chose these 4 time intervals because this is where things sort of transition. Meaning from time 0 to 2, I'm looking at, if this is the position, right, this is what I need to look for. I know it's teeny tiny and it's right up here, but I'm looking to see what's happening. So if I'm looking at the velocity in relation to 0, we're looking at what, the slope? So the slope in this case is what? Greater than 0? And then how do I look at acceleration? How do I figure that out?
Up or down?
Oh, concavity. So that means that is what? Greater than 0 also.
Yes.
So speeding up or slowing down? Speeding up. Okay, so remember when I said you had to justify? There's your justification. Okay, remember what I said before? Less is more. Less. Okay, from 2 to 4, talk to me. Velocity. Greater than 0. Acceleration. So then, slowing down. 4 to 7.
Negative velocity.
Yep.
Negative acceleration.
So I am
Speeding up.
speeding up. Okay. 7 to 10. And we just said 7. Okay, for consistency. Velocity is 0. So isn't acceleration also 0 because there's no concavity?
Yes.
So what's happening? Yeah, particle is not moving. Okay. Do we have any questions about that graph? How to break it up? Where we got positive negatives from? Okay. So this next portion, what we're about to talk about, is a big chunk of your homework because you literally have 3 problems for homework. And the reason why is because they're multi-step. Okay, so if you recall at the beginning of the year, I did talk about there are some occasions where you're going to get 2 to 3 problems, and the reason why is those problems are made up of so many different pieces that it's like you have 3 or 4 problems in one. I mean, that's kind of how calculus is. It's kind of how your test will be. Okay, so you had a question?
I just have one question on the last page.
Okay.
Why would it not say VT of 0 for the last one? Because wouldn't it only be 0 at that one point, and then acceleration should be 0? But
When we're talking about velocity and acceleration, we are referring back to T sub 0.
But if that's the case, then acceleration should also be 0, rather than just...
It's concave down at that point, though.
It's,
This is the position graph. It doesn't matter. The acceleration is concavity. At that can you tell me that that's a straight line?
That's concave down, not
At that
point.
At that point, it's still concave down. It's not a straight line. I mean, you could fight that because there is a horizontal tangent line, but it's not a straight line at that point. It's still concave. The graph is still concave down. I mean, I see your point, but it's. I mean, unless you zoom in on that, which I really can't because I don't have the function and I don't have the function in the calculator. I have to go based on what I have here. Okay, so the biggest issue that I've seen in the past is that people forget how to find all these pieces because everything is right here. Okay, so I want to go through this and I want to make sure that everybody understands, and what you need to highlight, I think, are the important pieces on how you calculate. So displacement. You will be asked for displacement. And the formula is your ending position minus your beginning position. So you are going back to the original function. And it is the change in the position of the particle over a given time interval. So you have to be given a time interval in order to calculate this. Okay, so really this is the end minus the beginning. Bless you. Total distance traveled in a given time interval. So distance is always positive. So even when the particle is moving in the negative direction, okay, the distance is going to be positive. And the reason why is you are going to take the absolute value of all the intervals. Even if it's positive, just take the absolute value. Okay? So we need to look at the intervals and what's happening in terms of those. And in this case, I'm going to tell you exactly how to do it, but this is dependent on the velocity function. Okay, one thing I do want to say about displacement too is that it can be positive, negative, or 0. So if displacement basically is a change in position over time, what does it mean if the displacement is 0?
It can move all you want, but it ended in the same spot.
Okay, so you came right back to where you started, right? Kind of like when you're running on a track, your displacement is 0, provided you begin and start in the same spot, right? Okay, so these are the steps. These are the steps to find the total distance over the given interval from A to B. So the first thing we need to do is find where the velocity is 0. So basically you find your velocity function, which is the derivative of the position, and you set it equal to 0. Then you are going to separate the intervals into positive and negative velocity. So what's going to happen is, typically you're going to be talking about time being greater than 0. So here you are at 0, then you're going to have some number here, and you're going to have some number here. Okay, and remember it's over some given interval, so this might be from 0 to 5, and then you're going to find the velocity at some given values. So you need to find out what the signs are in here. Okay, then you will calculate the distance traveled by substituting into the position function. Okay? And you will take the absolute value of the interval with the negative velocity. Remember, because you can't have a negative distance. And then you'll add up all the distances to get the total distance. And then just keep in mind that your distance traveled is always positive. Okay, this right here, if you are asked for it, I mean, this is so important. But I'm going to go through it when we do an example problem. So I'm going to take care of everything right here. But this is the biggest piece because people forget how to find the distance traveled or displacement. Okay, so here's our example. All right, so we're given a position function, okay, and we're told that our time is greater than or equal to 0. So this is what we're going to be working with. And the first part says determine the time interval when the particle is speeding up and slowing down. All right, so in order to do that, what you need to remember, and we just did it, is that we need both the velocity and the acceleration. So that means we have to take the first and second derivatives, and we need to find those critical numbers. So what we're going to have to do is calculate what the signs are over those intervals. So for A, we're going to take our position function, which is 3t cubed minus 18t squared. We're going to take the derivative. So we're going to find the velocity. So this is 9t squared minus, what is that, 36t. We'll take our velocity function and set it equal to 0. So I'm going to factor out a 9t. So it leaves me with t minus 4 is equal to 0. So we have critical numbers from the velocity at 0 and 4. 0 is actually the left endpoint. Okay? All right, so these are important right here. And I'm going to put a square around these, and you'll see why in just a second. Then we need to find our critical numbers from the acceleration, which is the derivative of the velocity. So what is that, 18t minus 36? Is that right? So if I take out an 18, that leaves me with what, t minus 2? So my critical number is t is equal to 2, and I'm putting that, should be in a circle, not in a rectangle. Okay. So in order to determine if my particle is speeding up and slowing down and over what intervals that is occurring, I need to put a number line here. Okay. And we would obviously start at 0 here because that is our, it says time must be greater than or equal to 0. And we're going to put all of our numbers from velocity and acceleration on this number line. So 0 is a velocity, 2 is an acceleration, 4 is a velocity. And I'm just putting these on here so you know where they come from. So on the top, I'm going to evaluate my velocity intervals, and on the bottom, my acceleration, so when I have them, I can compare the signs, top and bottom. Okay, that way, if you have two number lines, then you're like look at it's all on the same thing. So let's focus on velocity first. Remember, guys, we don't care what the value is, we care about the sign, S-I-G-N, right? Positive or negative. So if I plug 1 in up here, is that going to give me a positive or a negative value? Negative. Okay, plug in what? 3? Positive or negative? Negative. I don't know, 5? Because it says above, greater than 0. It doesn't say 0 to 7, 0 to 12. It doesn't say. So beyond here, positive. Okay, does everyone understand where those signs came from? Okay, so now we're going to focus on acceleration. So now I go down here, plug in 1. What happens when you plug in 1? What do you get? Negative. Plug in 3. Positive. Plug in 5. Positive. Okay, and this is for acceleration. So this is what I'm looking at. Here and here, I have the same sign. Here and here, I have opposite signs. So now this is my comparison. So when I'm answering the question in part A, I would say that the particle is, and let's use SU for speeding up, from where to where? 0 to 2 and 4 to infinity, right, because we don't have an end, and slowing down from 2 to 4. Yep. If you had to give justification for speeding up, you would say that velocity and acceleration have the same sign. Here, slowing down, velocity and acceleration have opposite signs. Zero and why are we not plugging in 0 and 4?
Why are we?
Because you have to compare the time intervals. So I need to know what's happening to velocity and acceleration from 0 to 2, because 2 is a critical number for acceleration.
That means at that point acceleration is equal to 0.
At this point, yes.
Okay.
Okay. Questions on part A? Okay. In part B, we want to know the total distance traveled from 0 to 6. Okay, so this question right here, do I use acceleration to determine any part of B? No. This goes back up to, in here, step 3. So in step 3, it says calculate the distance traveled in each interval by substituting into the position function. Okay, so this is what's going to happen. We need to use our velocity to determine our what's happening, like displacement. Well, total distance, but okay. So in part B, we're using our endpoint, so from 0 to 6, but we also had a critical number from velocity of what? 4. So this is what we're looking at. If I looked on the number line, we're going from 0 to 6, but I also have to consider what's happening between 0 and 4. And the reason why is if you go back to your velocity graph right here, what was the sign from 0 to 4? Negative. So distance can't be negative, right? So from 0 to 4, what do I have to do to that value? I will have to take the absolute value. Okay, and then from 4 to 6, we know velocity was positive here, but I'm still going to take the absolute value. Why? Just because, we can. So what we want to do is evaluate, the position at time 4 minus the position at time 0, because that's going to give me the distance traveled here, right? If I was 100 feet from where I started here, and I started off at 200 feet, you can figure that out, right? Okay. So this is going to be the absolute value plus the absolute value of S of 6 minus S of 4. Okay. So just to save time, this comes out to negative 96. Just to save you guys some time. Plus, it just so happens that this comes out to positive 96. That's a coincidence. It won't always happen. And you guys will have to evaluate it, because I won't be like, just to save you some time. Okay, so this is, what's my total distance then? 192. I don't. Can we say meters? Just cause. Okay, but do you understand why? The biggest part is because we had to make sure that we didn't get a negative value here. Even if we didn't take the absolute value, we wouldn't get a negative here, so it doesn't matter. But we did it anyway. Okay, here's the last piece, part C. Find the displacement from time 0 to time 6. If I go to the top, it's the end minus the beginning. So I would just have to evaluate S of 6 minus S of 0. Okay, S of 6. Oh, who has a calculator? Well, mine's right there. But so go into y equals, please. Somebody? Anybody? Bueller? And put in 3x cubed minus 18x squared in y sub 1. It's right here. Okay, and then if you go into the table, tell me what the value is for 6. No, 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 no. Isn't it 96?
For 6, I got 0.
It's 0. And then S of 0 is 0 minus 0. So tell me about this particle. The displacement was 0.
So it's ended in the same spot.
Yeah, it's right back where it started, right? Okay. Does that always happen? No. So let's say I got a value of, I'm just making this up, but let's say your value was negative 33 meters. What does that mean? You're 33 meters, or that particle is 33 meters to the left of where it started. Does that make sense? Okay. Sir?
Can you just add up B?
Yes. Okay, so, but it doesn't always happen. Yeah. So I was just using the application. Ben's like, yeah, just move on. Okay, so there is actually another piece where there is a graph that I want to go through, but I'm not going to do it until the next class because you don't have to do it in your homework. I think this right here is enough information to sort of overwhelm our brains enough, right? Okay, but the biggest piece is making sure that we understand and remember